Welcome to the Deep Dive, where we try to cut through the noise and get straight to the insights.
Glad to be here.
So today, we're diving headfirst into something that's, well, it's quietly but really powerfully shaping your world every single day. Think about it, right? When you ask Alexa or Siri for a recommendation, or you see those self-driving cars navigating streets, maybe even just getting useful search results. That's all driven by something pretty transformative.
Yeah, it's actually fascinating how deep it runs now. Often totally behind the scenes, like you said. Chatbots, social media feeds. It's kind of the engine under the hood.
Exactly. Perfect setup. So for this deep dive, our topic is data science. We've got some great source material, specifically a really insightful introduction from HAVY.ai.
Good stuff there.
And our mission, for you listening, is pretty clear. Cut through the jargon, really get what data science is, why it's so important, and how it's changing things. So for you feel really well informed. It's a crucial topic.
Absolutely.
Okay, so let's unpack this. First things first. What exactly is data science?
Right. So at its core, data science is basically the practice of taking huge amounts of data, structured, unstructured, big data, and processing it to find patterns, to get insights you can actually use.
Okay, patterns and insights.
Yeah.
But it's more than just number crunching.
Oh, much more. The really unique thing is how interdisciplinary it is. Think of a data scientist almost like a translator, fluent in stats, computer science, and the business side of things, bridging that gap between raw numbers and actual strategy.
So it pulls from different fields.
Exactly. It blends stuff like predictive analytics, machine learning, computer science, but also good old statistics.
And like we said, it touches everything. Those self-driving cars, the search results, they're not just cool tech, they're data science in action, right? Working for you.
Precisely. It really shows how baked in it is now. And, to really get data science, it helps to understand its life cycle. There's a structure to it. It's not just chaos.
Yeah, I'd imagine with all that complexity, it can't be
There absolutely is. It usually starts with capture. Simple idea, right? Getting the data. Acquiring it, extracting it from wherever it lives, getting it into your system. Kind of like gathering all the raw ingredients, messy as they might be.
Makes sense. Can't cook if you don't have the food, so after capture.
Then comes maintenance. This is huge. Organizing, cleaning, processing, storing the data. Things like data warehousing, data cleansing. This is where a ton of time goes.
How much time are we talking?
Well, the source points out something pretty surprising. Data preparation alone often takes up 60 to 70% of a data scientist's time.
Wow, 60 to 70%. Just prepping. That's like spending most of your time shopping and washing vegetables before you even start cooking. Why so much?
Yeah, good analogy. It's because data rarely shows up clean and tidy. It's usually noisy, maybe bits are missing, formats are all over the place, coming from different systems.
Right.
So you spend a huge amount of effort transforming it, sampling, cleaning, fixing errors, dealing with those missing values before you can even think about analyzing it properly.
Okay, so once that massive prep work is done, then the data scientist gets to do the cool pattern finding stuff.
Exactly. That's the next stage. Processing. And this is where they really get to work, using techniques like data mining, classification, clustering, modeling, starting to make sense of it all, summarizing initial insights.
It's like figuring out if an email is spam, maybe, or grouping customers.
Spot on. Classification for spam, clustering for customer groups, that kind of exploration, making sense of the raw material.
Okay, processed. Then it's the real deep analysis.
Precisely. Stage 4 is analysis. This is critical. You're doing exploratory work, confirmatory analysis, regression, predictive stuff, text mining, all the heavy lifting. And the source makes a great point here. There is no such thing as cookie-cutter data science when it's done properly.
Meaning each problem needs its own approach.
Absolutely. You might be using text mining on millions of reviews one day and predictive modeling on sales data the next. It's tailored.
Okay, analysis done, insights found. But insights stuck in a report don't do much right. How do you get them out there?
That's the final crucial step. Communication. Data visualization is key here. Charts, graphs, also reporting, using business intelligence tools. The whole goal is to help businesses, policymakers, whoever, make smarter decisions based on the data. Turn insight into action.
That's a really clear life cycle.
Yeah.
Capture, maintain, process, analyze, communicate. Got it. Which leads perfectly into sorting out some common mix-ups. Data science gets confused with related fields all the time. Let's start with data science versus data analytics. What's the key difference?
Yeah, this one trips people up a lot. So think of data science as taking the macro view. It's often about trying to formulate better questions to get more insights. It's exploratory, predictive, dealing with big, messy data, both structured and unstructured. It's kind of looking ahead, trying to figure out what could be.
Okay, data science is the forward-looking explorer. What about data analytics then?
Data analytics is usually narrower, more retrospective. It's focused on finding specific answers to questions that already exist. It looks at historical data, what happened, why it happened, and maybe suggests how to improve based on that past performance.
So, looking back mainly.
Generally, yes. And crucially, data analytics usually doesn't involve building complex statistical models or training machine learning tools in the same way. It's more about interpreting what's already there.
Got it. One looks ahead, asks new questions. The other looks back, answers existing ones. That helps. Okay, next pair. Data science and big data. We hear big data constantly. Are they the same thing?
Definitely not the same, though very closely related. Big data is essentially the raw material, the stuff.
The fuel.
Yeah, the fuel, characterized by what they call the V's: huge volume, incredible variety, unstructured stuff like emails, sensor data, structured stuff like transactions all mix up, and high velocity, how fast it's pouring in. Basic tools just can't handle it. They just choke.
Okay, so big data is the massive, messy pile of fuel. Data science is the engine that runs on it.
Perfect analogy. Data science is the approach. The scientific methods, the advanced algorithms you use to actually analyze, clean, process, and pull meaning out of all that big data. It's the whole discipline, the toolkit you apply to the raw material.
Makes sense. Okay, what about statistics? Feels like stats is underneath all of this somewhere. Is data science just like statistics 2.0?
Statistics is absolutely fundamental. It's a powerful field, providing the theories and methods for gathering data, interpreting it, checking validity, making predictions, inferences. Data scientists use statistical methods all the time. It's a core pillar.
But it's not the whole building.
Exactly. Data science is broader. It's interdisciplinary. It pulls in computer science, programming, business knowledge, economics, math, and statistics. It uses tools from all these areas to tackle these huge, complex data sets.
And the source mentioned something about 4As, specific to data science tasks.
Right, the 4As. Acquisition, architecture, analysis, and archiving. These highlight specific challenges. Acquisition isn't just getting data, it's wrestling it from messy sources. Architecture is designing systems for, well, zettabytes of data. Analysis, we talked about, it's bespoke, not cookie cutter. And archiving, often forgotten, but vital for checking work later and for compliance.
Right, each step has its own complexities. Okay, another one. Data mining versus data science.
Okay, so data mining is more of a technique. It's a specific process often used within data science or even just in business analysis. Its main goal is usually to make data more usable for a specific business purpose, often focusing on structured data. Think of it as a specific skill, like finding fraud patterns in transaction logs.
So it's part of data science, potentially.
Yes, it's a tool in the data science toolkit. Data science itself is the broader field. The scientific study aimed at creating data-driven products or outcomes, often starting with raw, unprocessed data and exploring possibilities. Data mining is one way to explore.
Got it. Technique versus field. Okay, now for the big ones, the buzzwords. Artificial intelligence, AI, machine learning, ML, deep learning, often used interchangeably. Help us untangle these and see how they fit with data science.
Right. This is where it gets really interesting and, interconnected. So AI, artificial intelligence. Fundamentally, it's about trying to get computers to simulate human brain functions. Things like learning, reasoning, self-correction.
Like in the movies. Skynet.
Well, that's general AI, the super intelligent, conscious machine. We're nowhere near that yet. What we do have is narrow AI. AI focused on specific tasks, like IBM Watson helping doctors by analyzing medical records. Still incredibly powerful, but focused. And AI needs tons of data to learn.
Okay, AI is the big goal. Simulating intelligence. Where does machine learning come in?
Machine learning, or ML, is a subset of AI. It's also a core part of data science. It's a process. Instead of programming rules explicitly, you feed the computer huge amounts of data and let it learn the patterns and rules itself.
So the machine teaches itself from the data.
Exactly. It uses algorithms to train itself, optimize its performance based on the data it sees. Think about teaching a computer to recognize cats by showing it thousands of cat pictures. That's ML. The data is the teacher.
Okay, ML is teaching machines with data. Then what's deep learning? Sounds deeper.
It is, in a way. Deep learning is a type of machine learning, which is a part of AI. It uses structures called artificial neural networks, which are loosely inspired by the human brain, often with many layers, hence deep.
And what's special about deep learning?
Its real power is in handling very complex patterns, especially in unstructured data. Think images, sound, natural language text. It can often figure out the important features on its own without humans needing to label everything perfectly beforehand. That's a huge advantage with today's messy, big data.
So let me see if I have this. Deep learning is a technique within machine learning. ML is a key part of achieving AI, and all of these fall under the broad umbrella of data science.
You got it. Data science uses ML and deep learning as powerful tools, but it also includes data preparation, statistics, visualization, domain expertise, the whole life cycle we talked about.
That clarifies things a lot. Which brings us to, why now? Why is data science so indispensable right now?
Short answer. The sheer, unbelievable explosion of data. The numbers are just mind-boggling. By 2020, the world had generated something like 40 zettabytes of data.
Zettabytes? 40 trillion gigabytes.
Yep. And get this, around 90% of all the data ever created was generated in just the 2 years before that. It's exponential growth on a scale that's hard to grasp.
That's, wow, just incredible. We're literally creating oceans of data every day.
We are. Internet users alone pump out about 2.5 quintillion bytes daily. But here's the kicker. Back in 2012, estimates were that only about 0.5%, 0.5% of all data was actually being analyzed.
So we're drowning in data, but starving for insights without the right tools.
Exactly. Your standard spreadsheet or old database just can't cope with this volume, velocity, and variety. Data science tools and techniques are essential to make sense of it all, to find the meaning hidden in that deluge. There's just so much potential locked away in data we haven't even looked at yet.
Let's make it concrete. Where are we seeing data science really changing things in the real world?
Oh, across the board. Take healthcare. Wearables are a great example. They're not just counting steps. Data science algorithms analyze that data stream to spot subtle anomalies in your heart rate or sleep patterns, potentially flagging a health issue way earlier than before.
Proactive health, basically.
Exactly. And on a bigger scale, the source suggests applying data science properly across the U.S. healthcare system could potentially slash spending by $300 to $450 billion. That's huge. 17% of the total cost.
Incredible savings and potentially better outcomes. What about finance? Always a data-heavy field.
Absolutely. Fraud detection is a massive area. Data science can spot suspicious transaction patterns much faster and more accurately than humans wading through data. It also helps banks predict loan defaults better by analyzing past payment histories, reducing risky loans.
Okay, healthcare, finance.
Yeah.
What about something like policy work? How does government use this?
Policymakers are increasingly using it. For example, using historical weather data and geospatial information to predict the path of a hurricane more accurately, helping decide when and where to issue evacuation orders. It can improve disaster response, resource allocation, potentially saving lives.
Really direct impact there. And finally, marketing. I assume it's big there too.
Oh, yeah. Companies use it to refine pricing, think dynamic pricing on e-commerce sites. They use it to target ads much more effectively, figure out who is most likely to buy. Predictive analytics helps them find the optimal price point or even predict which marketing campaigns will generate the best leads based on past trends. Much smarter than just blasting ads everywhere.
It's clear the power is immense. Which brings up the ethics side. With all this capability, how do we ensure it's used responsibly? Prevent misuse?
That's a critical conversation. Data science ethics are paramount. It's about protecting people. Key guidelines include things like only collect the data you actually need for the task. Don't just hoard everything.
Minimize the data footprint.
Right. And then protect what you do collect rigorously, using strong security. Transparency is also vital, being clear about what data you have and how you're using it. And guarding privacy, often by aggregating data looking at general trends, not spying on individuals.
So collect less, protect it well, be open, and focus on groups, not individuals.
That's a good summary.
Okay.
Plus, actively identifying and scrubbing sensitive data is crucial. A data breach with sensitive info isn't just bad for users. It's terrible for a company's reputation and can lose them customers. Good ethics is also good business sense here. Shows you handle data responsibly.
Very important points. Okay, let's shift focus to the future. What's next for data science? There's talk of automation. Will data scientists automate themselves out of a job?
The perennial question. It's an ongoing debate. The source suggests, and it makes sense, that the simpler, more repetitive, manually intensive tasks will increasingly be automated. driven by ROI, basically. Gartner even predicted back in 2020 that 40% of data science tasks could be automated.
So some automation, yes, but not the whole field disappearing.
Exactly. It's more likely an evolution. Automation will handle the grunt work, making data insights potentially usable by more people faster. This frees up data scientists to focus on the harder, more complex, more strategic problems. It probably accelerates AI and ML progress, too.
So it becomes more accessible.
That's another trend, yeah. Accessibility. More tools, more resources are becoming available, leading to this idea of the citizen data scientist. Maybe someone in marketing or finance who can do some level of analysis themselves, especially for specific business needs. The really complex stuff will still need specialists, though.
Democratization of data, to some extent. What about the privacy angle for the future, that tension you mentioned?
Right, that's a huge ongoing issue. Balancing the right to privacy with the need for data, plus regulation like GDPR, and this growing demand for transparency, especially around algorithms. Interestingly, data science itself might hold some answers here. Techniques are being developed to make ML models more interpretable, more explainable.
So data science could help make AI like the black box.
Potentially, yes. Which could help with regulatory oversight and building trust. It's a really active area of research.
Despite automation and accessibility, the human element remains key, right? We're not just handing it all over to machines.
Absolutely not. The human role is vital, especially in understanding the context. Translating fuzzy human needs into specific, answerable questions for the data, and then interpreting the results. Gleaning actionable insights requires critical thinking, domain knowledge, things machines are still very far from replicating well.
So understanding the why and the so what.
Precisely. People with deep business experience, industry knowledge, who can connect the data docs to real-world strategy. They'll remain incredibly valuable.
Okay, so the future is more collaboration between humans and machines, leveraging automation. Now, for anyone listening thinking, that sounds fascinating, I want in, what does it take? Can you actually teach yourself data science?
Well, in theory, maybe. But mastery is tough on your own. You can learn coding, learn stats online, sure, but putting it all together, understanding the nuances, dealing with messy real-world projects, that's challenging without some structure or mentorship.
So what are the core skills, the must-haves?
You definitely need a solid grounding in statistics. Probability, inferential stats, linear algebra, some calculus, it's math heavy. Then programming Python and/or R are the big ones. You'll likely need SQL for databases, maybe Apache Spark for handling really big data. Familiarity with different data science platforms helps.
And visualization tools.
Oh, yeah. Things like Tableau, maybe Power BI, Snowflake. Being able to visualize data is key. And of course, understanding machine learning, maybe natural language processing, NLP, deep learning concepts and tools like TensorFlow or PyTorch.
That's a hefty list. How do people get hands-on experience beyond courses?
Good question. Joining professional associations is great. Participating in hackathons, real pressure, real problems. Getting involved in online communities like Kaggle, trying to solve posted problems, that's where you learn a lot, practically.
Let's talk about those languages. R versus Python. Seems like the classic data science debate. Any guidance?
Yeah, it's the big choice for many. Both are super powerful for cleaning data, transforming it, analyzing, visualizing. R was built by statisticians for statistics and data analysis. Huge community, amazing packages for complex stats and graphics like ggplot2, really strong for pure analysis and exploration.
Downside star.
It can sometimes be a bit slower on really massive data sets compared to Python, maybe, and the syntax can feel a bit complex, maybe a steeper learning curve if you're not from a stats background.
Okay, and Python. Feels like it's used everywhere now.
It is. Python's more of a general-purpose language, often seen as more readable, maybe simpler syntax, potentially easier to pick up initially. Very flexible. Lots of libraries for data science, ML, everything. Tools like Jupyter Notebooks make sharing work really easy.
Any downsides to Python for data science?
Traditionally, maybe its out-of-the-box data visualization wasn't quite as sophisticated as R's best packages, though it's catching up fast with libraries like Matplotlib and Seaborn. Really, the choice often comes down to what you want to do, your background, maybe what your team or industry uses. Both are excellent choices.
And you mentioned visualization being key earlier. Just how important is it?
Hugely important. Critically important. You can stare at a spreadsheet of numbers all day and miss things. A good chart or graph can instantly reveal patterns, outliers, relationships that are basically invisible in tables.
Lets you actually see the story in the data.
Exactly. It guides your analysis, suggests new questions to ask, And it's essential for that communication step we talked about, sharing your findings with people who aren't data experts, using interactive dashboards and visuals. It bridges that gap.
Okay, let's wrap up with a deeper dive on a question many people wonder about, maybe even hope about. Can data science predict the stock market? Get rich quick.
Ugh, the million-dollar question, or maybe $1 billion now. It's a really common misconception, often fueled by how it's sometimes taught. But the source is pretty clear. The stock market behaves largely like a random walk.
A random walk, meaning unpredictable.
Essentially, yeah. Today's price is the best predictor of tomorrow's price, plus some random unpredictable fluctuation. There isn't some secret, perfectly repeatable pattern that data science can magically unlock for guaranteed profits. If there were, everyone would be doing it and the pattern would disappear.
So no crystal ball then. Bummer.
Haha, yeah, no crystal ball. But that doesn't mean data science is useless here. What it can do is help manage risk and understand probabilities. Using prediction theory, analyzing past volatility, correlations, data scientists can help predict a likely range for future values under certain conditions.
So not buy now or sell now, but more like, based on the past, there's an X% chance the price will stay within this band over the next week.
Exactly that. It's about understanding probabilities, quantifying risk, maybe identifying short-term inefficiencies based on specific data feeds. It's about making more informed bets in an inherently uncertain game, not eliminating the uncertainty.
That's actually a really important distinction. It's not magic, but it is a powerful tool for understanding probability and risk, even in something as complex and, well, random as the market. It frames its utility much better.
Precisely. It manages expectations but still highlights the value. Data science provides insights, probabilities, helps make smarter decisions within unpredictable systems.
Wow, what a journey through data science today. We've gone from the basic definition through that detailed life cycle.
Capture, maintenance, processing, analysis, communication.
Right, then its impact everywhere. Healthcare, finance, policy, marketing. We talked ethics, the future with automation and AI.
And the skills you need. R versus Python, the power of visualization.
Absolutely. Our mission was to help you, our listener, feel really well informed on this huge topic, drawing on that great material from HEV.ai. I certainly feel like we've covered a lot of ground.
It's been a really comprehensive look. It's just such a critical field for understanding the world now with all this data flying around.
It really is. Which leaves us with a final thought for you to chew on. As data keeps growing like crazy and machines start handling more of the routine stuff, what new, complex problems will you apply your uniquely human critical thinking to solve, using the power of data science? Something to ponder.